Hi, everyone. Welcome back to Let's Make a Better World. This is my fifth video, I believe, in my series on space travel. And today I'm going to talk about the vastness of outer space. I don't think most people realize how huge space is, in particular the observable universe, compared to the size of the Earth. So space is really, really big, and I'm going to try to give you an idea of how big exactly in this video. So let's begin. Well, this is kind of I guess, sort of a joke a little bit. But yeah, I used to see T-shirts that said "You are here." They show a picture of the Milky Way galaxy with a pointer to where the sun is. Sun. If you're looking at the picture of the whole Milky Way, you can't even tell. You can't even see the sun. It's minuscule, but it's about maybe two-thirds of the way out. I'll get to that later. It's about two-thirds of the way out from the center of a galaxy. But this picture is showing where the Milky Way is in relationship to, I guess, the Virgo supercluster or something. And, there's just a little bit of facts on this slide. There's upper bound is about 2 trillion galaxies in the whole observable universe. And there's estimated to be, I think, something between 100 billion and a trillion stars just in the Milky Way galaxy. So the number of stars in the observable universe is it's huge. I'm not gonna even say how big, but just the universe is really, really big. I'm gonna do things sort of one step at a time here to give you a better idea. And There's a very excellent movie that came out, I think, in the late '70s. It's called Powers of Ten. I don't know how many of you guys are familiar with this movie. It's a very short movie. It's only about 10 minutes long, but it's really excellent. What they do is they start with this man in a park in Grand Park, I guess, in the middle of Chicago. And I mean, you can see the seventh picture on this slide. The third and the second row shows him and his wife, I guess, on a blanket in the park, and then if you look at these pictures on the slide, if you just start with the first one, that's the whole Milky Way, and then each subsequent picture is a zoom in from the next one, and I think they skipped several powers of 10 in here. I don't know how many, probably do 3 powers of 10 at a time. So the size of the Milky Way is about 10 to the minus 21st meters. And then I guess the fourth picture shows the Earth, which is about 10 to the sixth meter. So I guess they're doing 5 powers of 10 at a time. And then they gradually zoom in further, and you see the fifth picture shows the hub of Lake Michigan, where most of Chicago is, and then they show a picture of downtown Chicago, and then the man on the blanket with his wife in the park, and then they're zooming in on his hand, and then they go into, I guess, what I like to call inner space there. So I'm not really concerned with this part in this video, but you can zoom in to proton. Finally, by the end of the movie, they show I guess a carbon atom which has 6 protons and 6 neutrons. And anyway, it's an excellent movie. I would recommend you watch it. And I'm going to try to do some of that in this video, but I'm not going to go in. I'm just going to go out. And I'm going to start with the Earth because that's where outer space begins. And the Earth, like I said, it's about 10 to the 6th meters, about a million meters, or no, 10 to the 7th meters, actually, about 10,000 kilometers diameter. As a matter of fact, I think that's how the meter was defined in the 18th century in terms of the size of the Earth. I think there's 10,000 meters. I think there's 40,000 kilometers circumference. That's how the size of the Earth got defined. So the diameter, I guess, in miles, I know it's 8,000 miles. I guess that's about 13,000 kilometers. And we're only interested in order of the magnitude here. So around 10,000 kilometers, around 10 million meters, 10 to the seventh meters. That's about the size of the Earth. And you can see, this is a really nice picture, by the way. I believe this is an actual photo. And you can see the moon and the distance. And the moon is actually very far from the Earth compared to the size of the Earth. Even though the moon is the closest heavenly body to the Earth, it's about 240,000 miles. I'm used to thinking in miles, even though it's better to think in metric. I guess in metric that would be about 400,000 kilometers. Remember, I said the Earth has a radius of around 6,000 kilometers, so it's about 60 times the radius of the Earth, or 30 times the diameter. That's the distance from the Earth to the Moon. And I believe this picture is to scale. And the orbit of the Moon is a little bit eccentric. That's why the Earth isn't exactly in the center of this orbit. Anyway, so that's a scale model of the moon, the Earth and the Moon. As you can see, the Moon is pretty far from the Earth compared to the size of the Earth. As a matter of fact, when the astronauts went to the Moon, they were able to cover the Earth with their thumb. They were able to extend their thumb as far as it would go, and they'd see the Earth in space, and they would be able to cover the entire Earth with their thumb from the Moon. That just shows you how far away the Moon is. And another thing I heard is every astronaut who walked on the Moon, I believe there were a dozen of them, 12 of them altogether. They when they came back, I think also the ones that orbited the Moon. There was six more, so 18. I guess a total of 18 astronauts went to the Moon. Actually, I think a few more because there were a few missions to the Moon that didn't land on the Moon. But anyway, every astronaut that went to the Moon, I heard when they all came back home, they thought about the Earth completely differently than the way they thought before. I mean, the Earth is the only place that most of us have ever been. For all of human history, we've all lived on this planet we call the Earth, and it's like everything we've ever known throughout history, and yet it's minuscule compared to the size of the universe. The observable universe is absolutely minuscule, and you don't even have to go that far to see how minuscule it is. You just have to go to the Moon, cover the Earth with your thumb, cover our home, the place that all of humanity is known for all of human history. You can cover it with your thumb. So just think about that a little bit. And this is I'm just scratching the surface. So that's just the Moon. And what about if you want to go farther? What about, this is a picture of um, I think this is the inner solar system, if I'm not mistaken. Yeah. I think that's the orbit of Jupiter on the outside here. So this is just the inner solar system, and I mean usually we call the inner solar system everything up to Mars, and and the Earth is the green orbit here. So this is the size of the Earth's orbit around the Sun. And this is already much, much larger than the size of the Moon's orbit. And the Moon's orbit, like I said, is about 400,000 kilometers. The size of the Sun's orbit is 150 million kilometers. So it's already like 400 times the size of the Moon's orbit. So remember, I was just saying how big the Moon's orbit is compared to the Earth. Well, now multiply that by 400. That gives you the size of the Earth's orbit. And the distance from the Sun to the Earth is known as one astronomical unit. It's about 150,000 kilometers. And that's a useful unit to know. And here's another picture. I like this picture better, actually. This on the right side is or on the left side is the inner solar system. This is just the planets up to Jupiter to scale. That's just what I showed you. And then if you want to look at the outer solar system, then look at the size of Jupiter's orbit in the second picture. They've shrunk it by about a factor of 10. So to get the whole up to Pluto, which isn't even considered a planet anymore now, I guess it's a dwarf planet. But Neptune, I guess, is the farthest planet from the sun. You'll notice that the orbit of Pluto crosses the orbit of Neptune. Sometimes Pluto's closer than Neptune to the sun, but most of the time, I guess it's farther. But anyway, this is the solar system to scale. And, to give you an idea, I didn't talk about the time it takes for light to travel. Let me just back up a little bit here. It takes about 1.3 seconds for a beam of light to go from the Earth to the Moon. So the Moon, if you like, is about 1.3 light seconds from the Earth. And by comparison, the sun is about 8 light minutes from the Earth, so that's much much farther. And then if you want to talk about the whole solar system, I think that the time it takes light to go from the sun to Pluto is like 5 hours. So 5 hours. So we've gone from just a little over a second to the moon to like 5 hours to Pluto. or 4 hours to Neptune, if you like. This is a useful table here. This table, if you look at, I mean, really don't worry about too much of this other data. Just look at the first column or second column. So the first column tells you the names of the planets. I guess they don't include Pluto here since it's no longer considered a planet. But then the second column tells you the distance of each of the planet, the average distance to the sun in astronomical units. And you notice the Earth is one astronomical unit by definition. So Mercury and Venus are closer to the sun than the Earth. Mars a little bit farther. And then if you go to the outer solar system, Jupiter and beyond, then you're already several astronomical units away. And the farthest one, Neptune, is already 30 astronomical units. That means it's 30 times as far from the sun as the Earth is. So it's quite a bit farther out. And and then you can go even farther. I mean, you can go to what's called the Oort cloud. It turns out that there's a cloud I think that was discovered pretty recently, maybe in the last 50 years or so. But it turns out that there's a cloud of ice particles known as the Oort cloud. It's a roughly spherical shaped cloud surrounding the sun. And I'm pretty sure that every star has an Oort cloud associated with it. I'm not sure how it got there, but there's these particles of ice or ice balls, if you like, orbiting the sun, and they're very, very far out. I mean, the outer portion of the Oort cloud, I guess the radius of the Oort cloud is about 150,000 astronomical units. That's a lot. I mean, remember I just said that Pluto was only 30, Neptune was only 30 astronomical units from the sun. And by the way, if you went all the way to Neptune, you wouldn't even be able to see the Earth. There's another excellent movie I've seen by I guess it's a clip from Cosmos by Carl Sagan. He zooms out from the Earth all the way to the orbit of Neptune, and by the time you get to the orbit of Neptune, the Earth just looks like a tiny little speck of dust. It gets to the point where you can't see it anymore. So that's just how big the solar system is if you don't even include the Oort cloud. That's 30 astronomical units. But now we're going out to 150,000 astronomical units, which is almost as far as the nearest star, Alpha Centauri. Alpha Centauri is about 250,000 astronomical units. That's also about 4 light years. So I guess the Oort cloud has a diameter of maybe 2.5 light years. Now we have to keep changing our units when we go to more and more vast distances. So now we're already talking about light years, and a light year is the distance it takes light a year to travel. Pretty amazing. I mean, when I first learned about a light year, I was really pretty awed by how huge a distance that is. Because light, nothing in the universe, as far as we know, can travel faster than the speed of light. And if it takes light 1 year to travel that far, then you just get an idea how big that is. In miles, it's about 6 trillion miles, or about 10 trillion kilometers. Almost unimaginably large distance. But that's the distance scales we're talking about here. And then, you can keep going. I mean, now we're just talking about stars, and the average distance between the stars is about maybe 5 light years or so. There's another unit called a parsec, which is about 3 light years. And I guess, one reason a parsec's kind of convenient unit is because stars are roughly 1 parsec apart. Yeah, but this is, I guess, some of the nearest stars to the sun, and this is just a 200. This is just the neighborhood with a radius of 250 light years. Um, I think there's a lot of stars they left out of this picture. There should be thousands of them. Pretty much all the stars we can see in the night sky, I'd say, are within about 250 light years. When you go any farther, they're too dim to see unless they're really, really bright stars. So that's kind of the solar neighborhood of stars. But then, you can go even farther out. You can go to the whole Milky Way galaxy. And the Milky Way galaxy is 100,000 light years in diameter, roughly. I guess 50,000 light years radius. And the sun, like I said, is about 2/3 of the way out. This is a picture that has a little pointer to the sun. It'd be funnier if they said you were here. But and then it shows some other features of the Milky Way galaxy. It's a spiral galaxy, pretty common type of galaxy. I don't think our Milky Way is really that unusual as far as galaxies go. Um, yeah, and this, I think I mentioned already that the Milky Way has about at least 100 billion stars. That's what they used to say. I think now there's estimates that it might have up to 1 trillion stars, and we're just one of them. And you can just imagine. I think it's extremely unlikely that we're the only one with intelligent life. Of course, we've been looking for the last 50 or 60 years with SETI, and we haven't found any yet. But that's what's called the Fermi paradox of life. But that's kind of beyond the scope of this video. But anyway, that's the Milky Way, 100,000 light years in diameter. That means it would take 100,000 years for a beam of light to go from one end of the Milky Way to the other. And actually, I guess one sort of explanation for part of the Fermi paradox is that imagine that there's a star with intelligent life on the say I don't know, on the other end of the Milky Way from us. So that would be like maybe 80,000 light years away. That means that they'd be seeing us like we looked 80,000 years ago when we were just cavemen then. And, if they could see us at all, they probably wouldn't be interested in us. So probably the only intelligent civilizations that would be interested enough in us would be those that could see us, maybe in the last 100 years. So, within 100 light years, we haven't been sending radio signals any further back in time than that. So, um, and then you can go beyond the Milky Way. You can go to what's called the local cluster of galaxies. There's about 20 galaxies in our local cluster. And the nearest one is the Andromeda galaxy. That's about 2 million light years away. Um, and I think the size of the whole local group is about 3 million light years. So now we're talking millions of light years, and this is just the closest 20 galaxies to us. So we're still just kind of scratching the surface on the size of the whole observable universe. And then if you want to get into a bigger scale, you get to superclusters. We're part of what's called the Virgo supercluster, and I believe the Virgo supercluster, I don't know how many galaxies it contains, but its diameter, I think, is in the hundreds of millions of light years. I don't know exactly how many. But now we're talking like 100 million years to go from one end to the other. I mean, the dinosaurs are, the most recent dinosaurs lived less than 100 million years ago. So we're getting to some pretty damn vast scales, and this is as far as I'm gonna go. So the yellow circle here, a yellow sphere. This is supposed to have the sun at the center. This is the size of what's known as the observable universe, and the Big Bang occurred 13.8 billion years ago. This is very accurately known now. So time, if you like, time as we know it, began about 13.8 billion years ago. And you'd think, because light can only travel at 1 light year per year, you would think that would mean that we can't see beyond 13.8 billion light years because it would take light that long to reach us. Actually, that's not true because space is expanding. The universe is expanding, as I'm sure you know. And the space can expand faster than the speed of light. As a matter of fact, it is expanding faster than the speed of light. That's why, even though the Big Bang only occurred 13.8 billion years ago, we can actually see up to 46.5 billion light years away. That is the radius of the observable universe. So we can see up to 46.5 billion light years from us. I mean, that's tremendous. And that's just the observable universe. We don't know what's beyond the observable universe. As a matter of fact, we can't know what's beyond the observable universe. If you believe that nothing can travel faster than the speed of light, which most scientists believe, then the observable universe is all we can see of the universe, and even in principle. But there's no reason to believe there's stuff beyond it. There probably is. Universe may be infinite as far as we know. But anyway, that just gives you an idea of how vast outer space is. It's tremendous. It's mind-boggling how huge it is, I think. And I just want to say one more thing before I finish. I don't know how many guys saw the Superman movies, the original Superman movies with Christopher Reeve, Superman, and Gene Hackman, I believe, as Lex Luthor. Margot Kidder as Lois Lane. But in the first Superman movie, which came out in 1978, I don't know if you remember, Superman came from this planet called Krypton, which was supposed to be in another galaxy. They don't say how far this galaxy was. I don't think it was that far, maybe in our local group. So maybe up to 3 million light years away. But at the beginning of the movie, there were these three evil aliens who got banished into this thing called the Phantom Zone. That's this little square mirror that's flying out. So their punishment for their crimes against Krypton was being banished into outer space in this mirror where they could never get out. And they were supposed to be in this thing forever. But then I didn't show any more pictures. But there was in the next movie, Superman 2. I don't know how many guys saw that one. The Phantom Zone just happens to be in the vicinity of the moon. I guess about 2 or 3 years later, where there was a hydrogen bomb that went off. Some terrorists set off a hydrogen bomb, which Superman saved the world by flying into outer space near the moon. But then the Phantom Zone just happens to be near the moon, and the hydrogen bomb explosion causes the Phantom Zone to break and free the villains, the arch villains. That's a plot of Superman 2. But what I think is really, really ridiculous about that plot, just think about the vastness of outer space the way I just described it. So imagine that Krypton, we don't know exactly how far away it was from Earth. I'm guessing maybe 2 or 3 million light years because it's it's in another galaxy, so it has to be within a local group. Maybe around Andromeda, which is Andromeda is the nearest galaxy, the Earth, which is 2 million light years away. So imagine it's that far away, and I guess it was Jor-El who launched the Phantom Zone into outer space, and then shortly after that, he launched his son Kal-El, who was really Superman, away from Krypton because Krypton was about to be destroyed. That's how Superman ends up on Earth. He travels through space for about 3 years. I guess it was time dilation, so that doesn't necessarily violate Einstein's theory of relativity. But he arrives on Earth as a 3-year-old kid, I guess in 1951. Then he grows up on Earth, and he becomes, I guess he learns his true identity as Superman in 1978 when the first movie was made. And then in 1981, the Phantom Zone, appears around the moon, and that's when the supervillains get released. But what boggles me about this is that unless it was intentional on Kal-El's part to launch the Phantom Zone and his only son in the same direction, the exact same direction, so that they'd both get near the Earth. I mean, think about this. I mean, the Phantom Zone was in the vicinity of the Moon, which is only a quarter of a million miles away from the Earth, and yet it came from 2 million light years away. And unless that was a coincidence, then I don't think that Jor-El would be so stupid to launch them both in the same direction. But assuming that it was just accident, what's the probability that that would happen? I actually calculated this once, and you have to realize that space is 3 dimensional, so you have to kind of multiply the difference in the scales between the size of the moon's orbit and the size of the distance from the Milky Way to whatever galaxy Krypton was at. That's about, I think, 13 orders of magnitude. You have to cube that because space is 3 dimensional. That gives you a factor of about 10 to the 40. So the probability that the Phantom Zone would just happen to be in the vicinity of the moon when the hydrogen bomb goes off is about 1 part in 10 to the 40, and I haven't even taken into account time. And what's the probability that it would occur at that time, right at the time when the hydrogen bomb just happens to go off? So extremely unlikely. And I haven't even touched on some other problems with the whole Superman saga, like the fact that that Superman can fly through outer space. That violates Newton's third law. He has to push against something. You can't have an isolated acceleration. So anyway, I might do another video at some point on problems with the physics of Superman and other comic book based stories. But anyway, that completes my video for today. Thank you for watching. Let's make a better world, and I'll see you guys next time. Bye.